just setting our final horizontal speed to 0, so make sure you add that in there as well. And then that really should be enough.
Phew, okay.
Run the game. And you see our moving platform there.
Right.
I jump on top of it.
Oh wow, look at
So
that.
now
That's
it
pretty
carries
cool.
along. Works perfectly.
Nice.
So yeah, thanks for watching, I hope that helped, and I'll catch you next time. Thanks guys.
Don't mention it. Alright, let's see if it works for me as well. Everything is ready, we have the platform in place. Okay, let's run the game. Here we go! Oh wow, it's perfect! Well, would you look at that, the wall collisions work as well. Neat! I wanna try to make it go vertically though. I mean, the logic should be the same. Everything's set up, time to test it. Awesome! What the... It's a bit of a rougher ride than I'd intended. Hey, what happened to the collisions? Come on, just get on there. What's the deal? Just stop falling through it. Just stay on it already. Come on, just stand on the thing. Why is it doing this? Why do these things always happen to me? It's doing this on purpose, isn't it? Seems familiar. Has this ever happened to you? Ever tried to copy somebody else's platformer code only to end up messing it up completely when you try to iterate on it by yourself? What, really? I thought it was just me. Well, according to some of these comments under Sara Spalding's original video, there are at least a couple of people struggling with this exact issue. Well, there were, like 10 years ago. Hey, better late than never, right? Well, anyway, I think I managed to figure out a solution to this problem, so TLDR, it's on screen right now. Put this code in the platform's begin step event and the vertical movement should work fine. Fair warning though, with this method, the platform will be able to move the player into walls, but only with vertical movement. So you'll need to figure out if you want to just maybe avoid those situations entirely or have it kill the player. It's up to you really. Now let's start from the beginning. Let's rewind to our horizontally moving platform. The player movement and collision logic is identical to Sara Spalding, so if you've been following her tutorial, you're on the right track. She has since moved on to a different method, but for most of her videos, especially the old ones, she uses a while loop to move the player object right up against the collision object. In this project I've also implemented a method to round the movement variables to integers. Otherwise, the movement of the player object is the same as in the tutorial. Now let's have a look at these platforms. The platform object is, of course, a child of the wall object, which is the object you set up the collisions with. The platform object turns off its collision mask when the player is below, meaning you can jump through it, but it turns it back on when you're above it, so that you can land on it. Of course, this means the platform will only work with the player object, so you have to keep an eye out for that. Also, in this project there is no way to pass through the platforms from above. It doesn't really affect my solution right here, so decide for yourself if you want it. On to the moving platforms. They're just like regular platforms, but they move. I have the direction change set to a timer. I also have the initial horizontal and vertical directions, the move speed, and the time limit set up in variable definitions. This is just to make them easier to edit in the room editor. Now, these lines are what it's all about. This is how the platform can make the player move. When the player is 1 pixel above the platform, as in on it, the platform sets the player's h-carry and v-carry variables to its own h-speed and v-speed respectively. For example, if a platform's horizontal direction is currently 1 and its movement speed is 3, this means that its horizontal speed is going to be 3, which means that this is what it's gonna set the player's h-carry variable to, as long as the player is on the platform of course. Then the platform is going to execute its own movement, moving 3 pixels to the right. When the player's movement is calculated, it will add 3 to its own horizontal speed, meaning if the player is standing still, it will move 3 pixels to the right, just as if the platform was carrying it. Okay, so this should work along both axes, right? Well, let's see what happens when we add v-carry to the mix. It seems like the player's movement is lagging behind the platform, doesn't it? The platform moves down and leaves the player up in the air. Then the player object realizes that it should fall and it falls down. Well, at least it's working when it's going up, right? Not exactly. If I turn on my own little debug mode here and make the hitboxes visible, you can see the player is actually floating like 2 pixels above the platform. So which moved first, the platform or the player? To understand this, we need to look at the object's creation order. You will find that in the room editor. The objects will run their code in the same order as they are created. In our current example, the platform moves after the player. This makes sense if you look at what's happening. The player is standing on the platform, right? As far as the object is concerned, there is solid ground under it, so there is no reason to fall. Then the platform calculates and performs its movements, so moves down basically. Then it tries to move the player, but remember, there is no player above it now. The player will in fact stay in the air until the next frame, until it falls and lands on the platform again. So instead, let's move the platform after it has a chance to move the player. Well, that's not much better. Now, when the player is checking if there is a floor under it, it sees nothing. and then the platform moves into position. So at the end of the frame they are touching, but as far as the player object is concerned, it's in the air. Okay, so what if we change the order in which the objects take their turn? Let's say the platform moves first, then it moves the player, then the player object checks if there is a floor under it. Now theoretically, you could move the objects around in the creation order, but I think this is a bit of a clumsy solution. First of all, this is something that you'd have to keep in mind for every single room. In fact, every time you change the room, like adding a new platform to it, you'd need to change the creation order again. Also, if, let's say, an object creates a platform object while the game is running, now once again your creation order is messed up and there is no way to influence that. Let me instead introduce the begin step and end step events. These function identically to the step event, meaning the code inside of them runs every single frame. But the begin step event has priority, while the end step event is always run last. Or as the manual puts it, every frame all instances run their begin step event first, then all instances run their step event, and finally all instances run their end step event. This is a very useful tool if you want to call some functions out of order. So let's do it right now. Let's put everything the platform has into the begin step event. It'll get to move first, and only then will the player's code run. Let's check it out. Huh. I think that might be even worse. Well, that's because I was doing a bit of lying for dramatic effect. Obviously, the platform doesn't actually move the player. All it does is it tells the player how fast it should be going during its own step event. So the player lands on the platform, then the platform tells the player object that it should move 2 pixels up. Then it moves 2 pixels up itself. The player first checks if there is a floor beneath it, which at this point there isn't. Then it moves 2 pixels up, and then it continues falling. At this point I was getting desperate. I felt like I tried everything and there was no solution in sight. How do we make these objects move at the exact same time? Well, by brute forcing it, and making the platform actually move the player. Forget the V carry. Let's just make the platform change the player object's Y coordinate directly. And there you go, it works. At this point you can even set up the platforms to go diagonally, it works just as well. It doesn't feel jittery, there is no falling through the platforms. The only thing you really have to look out for with this method is that the platform will be able to move the player into walls, but only with vertical movement, so again, that's just something that you might want to avoid. And let me also reiterate that this isn't the definitive best solution to this problem, but it worked for me, and depending on the kind of project you're working on, it will work for you too. If nothing else, I think finding a solution was good exercise, so if you find a better way, feel free to share. And if you've made it this far, thanks for watching.